In this GPS tracking system, be able to track our location, our position, locate our current location, and locate the destination. And we can find with this GPS app, we can able to find the shortest path from our current location to the destination. Okay, so even can also shows the bus route, bike route, and car route, all those things, right? So similarly, in mobile gyroscope, so it is specially used in gaming, right? So based on the tilting range, tilting angle, tilting sloping speed, tilting speed, it can operate the game toys, no? So that is the main use of mobile gyroscope. And next one is the adaptive brightness. This is the most important thing our mobile, no? So when we expose our mobile sunlight, means the mobile brightness will automatically increase based on this adaptive brightness sensor only. So this is also an IoT system, and also another one is voice detection. So even most of us use mobile app, voice detection app in our mobile for typing any word, or enable our mobile to ring a person from our mobile through voice, or we can control a device through our voice. These things are happen through voice detection IoT. So another one is face detection. So with the help of face detection, we can able to unlock our phone, unlock our app, unlock our security folders. So this is also comes under IoT. The camera is capture your face, and process that faces, and then based on that output, it will unlock your mobile or unlock your app. Other than these, some other applications also there. So that is home automations. So in home automations, we can able to control any device from our home through our mobile app IoT devices. So we can able to control the locks, can able to control the security system. We can see the CCTV from our home remotely. We can also able to see the CCTV view, and also we can able to create a sound to alert any person. So based on the detection, it will raise an alarm. And also, so we can able to install a security system. If someone intruder enter into the house, it will the house will IoT device, it will based on the detection, it will raise an alarm. So, and also not only that, we can able to control light, fans, AC. We start from our office, can able to switch on the AC through our mobile app. So while we reach to our home, the home will completely enabled. That is, lights are will be switched on, and AC will be switched on, and it will reach that our predefined temperature within while we reaching that. While we reach the home, in automobiles, we can able to track our car location and speed of the car, and also we can able to identify the engine position, what are the service we have to do. All those things we can able to track with the help of IoTs. Nowadays, yeah, these things are possible. So another example. So nowadays, our Chennai traffic rule violation system is implemented in this system. So if anyone violate the rule, that is, if anyone cross the line during the signal, means what will happen, the CCTV will detect the car number plate, car or bike number plate, and that number plate will be sent into cloud. That from that frame, it will detect the number plate numbers and match that number to corresponding person's mobile phone. And based on the rules violation, it will generate a fine. That fine will be sent it to that particular person's mobile, either in the SMS way, or through WhatsApp. So these are the thing will happen in the current traffic rule violation system. Here we use one embedded system. The roadside, that is the CCTV. The CCTV will be enabled through with the help of line detector. So it detects whether the person is crossed the line or not. So based on that, the camera will trigger to capture that vehicle number. That number will be sent it to detector number will be sent it to stored unit, that is main centralized database unit. In that, we are going to capture that mobile number of that vehicle's owner, and then based on that fine amount, it will calculate it. That is based on the traffic rule violation, it calculate the fine amount. That fine amount will be sent into that vehicle's owner mobile number. Next, we need to, so already I told you that the embedded system comprises of 2 or more embedded systems. Those embedded systems are connected through internet. To develop an IoT system, we need to create embedded system. So that embedded system will be worked in the end-to-end device. To develop an IoT system, we have to know what is embedded system, and also we need to learn to know how to create an embedded system, right? So here embedded system, here I shows the basic block diagram of embedded system. It comprises of input unit and output unit and processing unit. So those data will be sent to either in wireless communication or wired communication. So here input devices are maybe keypad or sensor or switches, whatever. These are all comes under the group of input devices. It is used to get information from the surrounding environment, or manually it will get the information from a human. So those information will be sent to a processor. Based on that information, the processor will be process the data, and based on the data, it will trigger the output devices. So here output devices are display unit, maybe solenoid valve, solenoid lock, solenoid trap, or motor, DC motor, AC motor, servo motor, relay. So whatever maybe, these are all comes under the group of output device. So based on the sensor data, the sensor data are given to processor. Those processor will process the data. Based on the sensor data, it will enable or trigger the output devices. Here I shows the some sample sensors used. So first one is temperature and humidity sensor, and second one is light searching sensor, infrared sensor, and smoke detecting sensors, vibration sensor, clock sensor, ultrasonics, etc., etc., etc. So all these sensors are used to collect the data about environment. So let's take an example of temperature and humidity sensor, which is used to collect temperature and humidity of a room. So that data will be sent into a processor or a microcontroller. So based on the data, it will if the room temperature is higher, mean it automatically switch on the AC based on that input only. If the temperature is very low, what will happen? The processor will enable heater. Similarly, the light detecting sensor, if the light intensity is very poor, I mean, what will happen? It will automatically ignite the light. So in the street light application, we use this sensor only. So next one is output device. So these output devices are controlled through our microcontroller. It will enable or disable the output devices. So here relay and stepper motor, solenoid lock, solenoid valve, voltage unit. So these are all comes under the group of output devices, and display units also comes under the group of output device. In embedded system, we need to know we have to end device, that is sensors and output device, and another one important device is microcontroller or microprocessor. So that is the main thing which is used to process the sensors data. Based on that only, it will trigger or enable the output device, right? So we have to choose our microcontroller or microprocessor based on the requirement. Okay. If our application required more complex application, mean we need to choose a higher end processor. Similarly, if our application is required as or a minimum amount of processor, it required only 500 MB RAM or 250 MB RAM, means we have to choose that type of microprocessor for our applications. So here I compare three different embedded development kits. So first one is Arduino, second one is NodeMCU, and third one is Raspberry Pi. And the microcontroller types in Arduino is Atmega, and in the NodeMCU they use ESP8 266, and in Raspberry Pi it uses Broadcom BCM, and in real-time application the Arduino is used for robotic applications. NodeMCU generally used for home automations. Raspberry Pi used for OS-based home automation and robotic applications. And programming language in these three embedded development kits are C, C++, and in NodeMCU, they utilize C, C++, and MicroPython, where in the case of Raspberry Pi, we can use C++, Pythons, or C. Okay, in Linux also we can able to use this. And connectivity in Arduino, that is to add Wi-Fi, we need to add one more module. To control that device through Bluetooth, we need to add one more module. In NodeMCU, that is built-in Wi-Fi is there, so we can able to program through Wi-Fi. So where in the case of Raspberry Pi, we can able to program it or control through Wi-Fi and Bluetooth. Yeah, the Raspberry Pi has more advantages compared to other embedded board development kit. So in the complexity, the Arduino is very simple. In the Raspberry Pi, the complexity is higher. The common applications in the Arduino, we can able to use it for home automation, robotics, and data logging. And in the NodeMCU, we can use it for smart home devices, that is in embedded systems, sensor nodes. And in the case of Raspberry Pi, we can able to use it as a home automation main control unit for home automation unit, and IoT gateways, web servers. From this analysis, we can able to come to know that for computational complexity problem, we need to choose Raspberry Pi. Like IoT application, AIoT applications, face deductions. For this application, we need to choose Raspberry Pi. For simple Wi-Fi controlled embedded device, we need to choose NodeMCU for our application. For basic embedded applications like robotic robots movement, like that, we need to choose Arduino. So based on your application, you can choose your embedded development board. So in this from this analysis, I come to know that Raspberry Pi is best for my applications. So because I'm going to use AI application, IoT applications, and basic embedded